Okay, so hello and good morning, good afternoon, good evening, ladies and gentlemen. Welcome to the last webinar from our AWS Discovery Day. I'm so glad that I see so many people are joining us for this last webinar. I believe we've actually saved the best one for the last. So, if you keep constantly hearing everybody talking about machine learning, artificial intelligence, maybe deep learning, neural networks, things like that, and you really have no idea what it actually means, then you came to the right place, because in the following hour and bit, I'm sorry, I just got muted for some reason. So in the following hour and a bit, we will uncover, what the machine learning is, how does it actually work, and what can we do with it. So everybody buckle up. Don't worry, it's not going to be very, very technical. So we do not expect, you to know advanced mathematics and advanced statistics. We'll try to keep it high level, but we'll try to, dig in and explain on some example, what machine learning is and how machine learning actually works. So I'll be your instructor for this webinar. My name is Tomas. I've been working with AWS for almost a decade now. I'm kind of like AWS geek. I also have a minor with quantitative analysis. If anybody wishes to, stay in touch and talk, if you have any questions, even after this webinar is over, there is anything from AWS world that interests you, there's a QR code that's linked to my LinkedIn profile. Feel free to send me a message there. I'll be super happy to keep discussion about AWS going. So if anybody's interested, you can find me on LinkedIn using the QR over there. Now, I promise you to uncover machine learning. So why don't we actually do just that? We're going to use a little analogy. So imagine that you have a website, and on your website, maybe an e-shop like Amazon.com, and on the website, you want to add some product recommendations. So essentially, if a customer, buys a product, you also want to recommend the customer to buy other products that might be relevant for the customer. So obviously, this thing is nothing new. This is something that's been around, since the first eShop was out there on the internet. So obviously, the developers in the past had to solve this problem without any knowledge about, machine learning, artificial intelligence, or these technologies. So essentially, what was done in the past, how developers tackle these problems in the past, it was pretty much hard coding the recommendation based on the rules. So imagine that if a customer buys a cell phone, you're going to recommend him a red case for that cell phone, because you had a different customer that bought that particular cell phone and bought a red case for that particular cell phone. So essentially, what you're going to do, you're kind of going to hard code all of these if rules. So if customer purchase products X in the past, then show them product Y. And essentially, you're going to keep adding and adding and adding these rules. So over the time, it's going to be pretty complex. It's going to be pretty complicated, because you're going to have so many of these if, bought this, then recommend this rules. So that's a problem that can be actually solved using the machine learning. So machine learning, by contrast, would actually let us use a variety of data that we've aggregated in the past. So not these hard-coded rules that we have to do, but we're actually going to take a look at data, all of the relevant data, all of the data that we have at our disposal, and we will try to derive patterns that's hidden in the data. So maybe something that we can't simply see. If you print out all of the purchase history, you can have, I don't know, thousands of pages of purchases. If you just scroll through the pages, probably you won't be able to recognize any of these patterns. But these patterns, they're there hidden in the data, and that's why we're trying to use machine learning. So trying to create a model. The model will try to identify all of these patterns, and after we have it, after we've identified these patterns, so we've created our model, we can actually use this model on any new purchases. So then we have our model, customer purchased something new, and we can use that newly created model for the recommendation. So this is the difference. We're not hard coding any rule. We're trying to create a model that actually learns from the data, that tries to identify all of these hidden patterns that they were in the data. So a little bit about machine learning. For machine learning, we're essentially trying to use as much data as possible. So all of the data that you have, even the data that, maybe at the first, when you think about it firstly, it might not look, they might not seem relevant, but try to use them, try to get as much data as possible so we've got enough data to train our machine learning model. So we've got enough data to actually find out the customer's behavior, so we can use all of this information to uncover these hidden patterns, and we can use this hidden pattern for future recommendations. So what we're trying to do in machine learning model, what we're trying to do in machine learning is to create this model. But what is actually this model? I know I use this term model without any further explanation, so let's actually do that. So machine learning model is actually a trained algorithm. Sorry. So it's a trained algorithm that we use to identify patterns in the data. So the training is actually very important. So imagine it's kind of like a learning process. So the machine learning needs to learn. It needs to take a look at data. It needs to learn the pattern. And after the machine learning did its learning, now we've got the machine learning model. So this machine learning model, this is the result of this machine learning process. In contrast, in the past, imagine we had these developers that had to hard code the rules. Now we don't do this anymore. We're simply going to let the machine learning to learn itself. So if you were to take a look at some of the machine learning algorithms, so these end results, you'll probably see something very, very complex, but I want to simplify it for now. So here on the slide, we've got an example of a simplified algorithm. But in the simplification, we have the important components that we actually see in real life. These important components are these features, this x0, x1, all the way up to xn. So we've got features. And we also have weights. This is that A0, A1, all the way down to the AN. So these are the two important components, features and weights. Let's take a look at the first one. So the feature. Feature is something that is important as an it's something that is identified as an important part in our algorithm. For instance, maybe if you have this recommendation website, you're selling some accessories, maybe a feature for us could be, is that product that was sold a hat? So if we sold a hat, the value is going to be 1. If the product was not a hat, the value is going to be a 0. So this is going to be our feature 1. Maybe our feature 2 can be if the product was a t-shirt. Again, if it was a t-shirt, it's going to be 1. If it wasn't a t-shirt, it's going to be a 0. Then we can go on. We can keep adding, as many features as we want to keep the algorithm relevant. So this is an example of the feature. Obviously, not every single feature is going to have the same importance for the final result. Some of the features might be more relevant. For instance, imagine the situation that customer buys a cell phone. Maybe you'll be now more inclined to recommend the customer cases for the cell phone. So these set of features will be more relevant. So these set of features will have a higher weight. So the weight is how much does this feature affect the accuracy of the prediction. So on the weight, we usually go on the scale from 0 to 1. If you have 1 or close to 1, this means the biggest importance. And as we get on the other hand, on the other side of the spectrum, so the closer to the 0 we go, the lesser important it is. For example, for us, the customer purchased 8 head in the past, so we're going to put weight 0.8. So essentially, that's how the machine learning algorithm is going to look like. We're going to have the combination of features and combination of weights. So for instance, here we can see another set. So there's a second example. It's going to be about particular brand the customer might be interested in. So for instance, if the customer is interested in this particular brand, we put it high. So we've got this yes one. And the relevance for us, the weight for us, is also very, very high. So we're going to put there a high number. Down here, different example for us would be if customer would be less interested in it, if that particular feature was less important in the overall prediction, we would put the weight value a little bit lower. For instance, 0.25. Now, after we've created our algorithm, so after we've identified all of our weights and all of our features, we need to use it for the final evaluation. So here we've got a very, very simple example, a very simplified example of the machine learning algorithm using the features and weights we discussed in the previous 2 slides. If we do a little math, we find out that the result of the calculation is 1.05. This result is higher than 1, so that particular product is probably something that we can recommend. So we find a suitable, we find an acceptable recommendation. Now, so this was a very simplified example of how machine learning works. There are actually several types, several categories of machine learning algorithms. So what do we have? We have supervised learning, unsupervised learning, and reinforcement learning. So we've got 3 major categories of machine learning algorithm. Let's actually talk about them in more detail. Let's start with the first one. Let's start with supervised learning. So with a supervised learning, you can imagine a supervised learning as if you had a teacher in the room, and if you're actually taught, if you actually identified all of the outcomes for your machine learning algorithms. For example, maybe you're trying to teach your machine learning algorithm how to identify cars. You have pictures, random pictures, and what you're trying to do, you're trying to identify if there is a car in a particular picture. So what you're going to do, you're going to grab a whole bunch of examples, and you yourself are going to say, all right, there is a car in the picture. So you're going to do something which is called labeling data. You're actually going to help your algorithm a little bit. You're going to do a bit of work. Imagine like a student. So imagine the machine learning algorithm like a student. Essentially, you're going to teach your student how you're going to teach your student, you're going to teach your student to learn by example. So you're going to give your student, you're going to give the machine learning algorithm a set of label data, so set of recognized cars, and now it's going to be up to the machine learning to trying to discover, so how does that car actually look like? So the machine learning is then able to recognize a car even in an unknown image, even an image it hasn't previously seen. So essentially supervised learning, this is this learning by example. I'm going to tell you, okay, from these 100,000 pictures, this is these are the correct ones. Now it's up to you to learn how does the car look like as an example. So the machine learning can then use this training to identify even cars in the picture it has never seen before. So this is an example of supervised learning. There are actually two types of problems that we very commonly solve using the supervised learning. First kind of problem is called classification. So we've got binary and multi-class classification, and the second one is regression. So classification and regression. So with the classification, as we've already said, there are actually two types of classification. We've got a binary classification, and in the binary classification, we're trying to say yes or no. We've got two categories: true, false, yes, no, maybe fraudulent transaction, not fraudulent transaction. So we're trying to put things in two categories: yes, no, or fraudulent, not fraudulent. It can be whatever categories it's want. Sometimes, of course, there's not only two categories, but you might actually have 3, 4, 5, or different number of categories. Imagine a situation that you have a customer calling a call center, and now you need to quickly get through the customer to a relevant agent. So now it's not going to be agent 1 or agent 2. It might be IT support, returns, accounting, and many other departments or division. So in a multi-class classification problem, we do have multiple categories, and we need to choose the correct category for us. The last one is a regression problem. With regression problem, we're no longer mapping an input to a defined number of categories, either 2 categories for binary or n number for the multi-class classification, but now we're putting an input to a continuous value like integer. Probably the best example for the regression problem would be trying to predict the stock price tomorrow. As you can see, we don't have like 2 categories or even like number of categories. Stock price can be pretty much any number. So what we would try to do with regression problem, we would try to estimate, let's say that the stock price for certain company would be, I don't know, $250 tomorrow. So this is the regression problem. We're trying to come up with a certain value. So all of these 3 were example of supervised learning. So this is the problem when we have label data, when we are the teacher, and when our algorithm is learning by example. In addition to supervised learning, we also have unsupervised learning. So with unsupervised learning, now there is no supervisor, there is no teacher in the room. With unsupervised learning, it's now to the machine learning algorithm itself to try to identify the labels, so try to identify the correct outcome itself. So now we're not going to tell the machine learning algorithm, hey, there's a car in this picture, there's a car in this, there's a car, so you need to learn how the car looks like. With the unsupervised learning, we're simply going to provide the data, wish our machine learning algorithm good luck, and hope that it can learn itself. It can identify the hidden patterns itself. There's actually a very common subcategory. So just to explain it on an example, there is something which is called a clustering. Imagine that you're trying to analyze customer purchasing habits. You have customers, who've purchased a lot of different products and from a lot of different companies. So we've got a situation right here. All of that, purchase would be represented as a dot. And now essentially we're going to give all of this data to the machine learning algorithms, and we're going to let the machine learning algorithms to try to find clusters. So essentially it will try to find these clusters. Here we can see the 3 clusters. So essentially we've got 3 groups of data that have something similar, something in common. So clustering, we're trying to find these clusters, trying to put all of these data sets that we have available in some of these categories. For example, here we found 3 clusters, so we would try to put all of these, all of our values into one of these 3 categories. So this is clustering, very common example of unsupervised learning. As you see, we're not telling the algorithm anything, simply providing data. Now it's up to the algorithm to find these groups, these clusters. Another very common use case for unsupervised learning is anomaly detection. So imagine the situation that we have speed cameras. We have speed cameras in the city, and the speed cameras, are checking the speed of all the cars that go through. Now the question is, so we can see, we can see the hour of the day, and on the x-axis, on the y-axis, we can see the vehicle speed. So as you can see, most of the vehicles that were, within the speed limit, let's say. Now, it is up to us to actually identify if we have some anomalies in the data, if it's actually maybe like a hardware failure, so maybe a speed, maybe a speed camera, the hardware of the speed camera didn't work, or if it's simply, a few people that ran just really, really, really fast. So if we're trying to detect this situation, if we're trying to do this, what's called anomaly detection, try to discover if this is a real, car that was speeding, like a Formula 1 car that was speeding too much, or if perhaps, that measurement was caused due to the failure in the equipment. So another great example of unsupervised learning is the anomaly detection. So we've talked about supervised learning, so having a teacher in the room and learning by example. We've talked a little bit about unsupervised learning. This was simply providing the data, all of the data, and now it's up to the machine learning algorithm to try to identify all of these patterns hidden in the data. And as promised, we've got 3 categories, so why don't we take a look at the last category, which is reinforcement learning. So probably the best example of the reinforcement learning is the AWS Deep Racer. If you're familiar with the AWS Deep Racer, AWS Deep Racer is the little car that drives itself onto the track. And you can actually try to create your own machine learning algorithm, so you can teach the car to drive itself on the track as quickly as possible without going off the track. So this is something which is called reinforcement learning. Essentially, reinforcement learning is learning through trial and error. So essentially, what's going to happen? There are going to be simulation. The car is going to just simply run some direction, and the car is going to learn by either getting a reward, so doing something good, going positive direction, or getting a punishment. So it's the trial and error. Essentially, if you do good, if you stay on the track and you fast, you're going to get a reward. Awesome. If you go off the track, you're going to be punishment. And these simulations are happening over and over and over. There can be millions of these simulations. And ideally, the car will continuously be getting more and more rewards and less punishment, so it can learn how to drive itself onto these track. So this is the reinforcement learning. There is an action, so the car will go some direction, and now the car will be either rewarded or will be penalized. So we'll get a reward or will be punished. And the car will do it over and over and over and over and over, trying to go over the track. And as we said, the idea is that as this simulation go forward and forward, the reward part, the car will be getting more and more and more rewards and less penalties. So it will try to learn how to drive itself on the track. So this reinforcement learning, this is the technology that's used, for instance, in these autonomous driving vehicles. Even if you have a different one, if you have like Tesla or something like that, that's most likely the algorithm that was used to train the car to drive itself. So I will talk a little bit about machine learning. Now, maybe you've heard another term that's also commonly, that's also out there, that people like to use quite a lot, which is deep learning. So what a deep learning actually is? Well, deep learning is actually part of the machine learning algorithm. So as we were talking about machine learning, deep learning is actually a part of it. So it's actually a part of machine learning. Deep learning represents actually a huge leap forward in our capabilities for machine learning, because the theory about deep learning, goes back in the decades, but there has never been available hardware to actually run these deep learning algorithms. I've got a great news. Nowadays, we do actually have available hardware. So now we can run the deep learning algorithms. Maybe if we were to compare it, so imagine that you want to create an algorithm that can play chess with you. So what could be done in the past? In the past, when we were talking about is like traditional programming, so what you could do, you could write down, all of the possible rules, and the machine, can learn based on the rules that you've written. So that's, something that could have been done in the past. Now, when it comes to machine learning, we can actually make this much better. So with the machine learning, the machine can actually learn and improve by analyzing the games that were played by humans. So now the machine is no longer depending only on the rules. It knows the rules, but also you're going to feed it all of the games, all of the game records that you can find, ideally from the good records. And the machine learning algorithm is actually going to go through all of these past games, and is going to try to identify, some potential improvements. So it's actually going to even try to identify how to improve over the games, how to improve based on some hidden pattern that perhaps a person didn't see. So that's how we can use machine learning algorithms to do that. But the last one, we've mentioned this idea of a deep learning. So with a deep learning, we can even take it to the completely different level, because with the deep learning, we're able to create machines that can actually learn to play chess more in a similar way how we do it, so by playing with it. So essentially, with the deep learning, machine could be given the most basic rules, how the chess games is played, and then the deep learning will essentially try to play games with itself, try to find some complex chess strategies, and recognize the pattern that traditional machine learning algorithms could not simply do. So essentially taking the machine learning to a completely different level. If you're curious about this deep learning, how does it actually work? With the deep learning models that we use today, we rely on things that are called artificial neural networks. So these artificial neural networks, they got an inspiration actually from the brain, from the human brain. So if you're familiar with the how human brain is, we've got the neurons, they've got axons, they essentially collect all of the incoming signals and produce some sort of an output. So this is essentially the same idea with the artificial neural network. So in the artificial neural network, we're going to have certain layers. These certain layers will take, all of this incoming information. So income information from the previous layer, run some calculation, and then produce a final output. So feed the information to the next layer. So essentially, if you think about it, it kind of like the idea kind of like simulates the analogy of the human brain. So deep learning is different when we're talking about features, the importance, and how they're actually used in a classical programming and even in machine learning. Let's take a look at how do we use a feature in a deep learning. Essentially, in a deep learning algorithm, we do not need to provide any of the features. So something that we had to do previously, because that artificial neural network during the training process can automatically derive appropriate features. So as we said, the deep learning, it's kind of like if the machine plays with itself, it tries to learn, the best strategy, how to beat anyone in chess. So this is the idea. We're not going to tell the machine, okay, you need to use this, this, and this, and this. Now we're simply going to let the machine play with itself and try to figure, try to discover all of these features by itself. So a great example, when we can use this artificial neural networks, so when we can use this deep learning, is the image classification. So let's take a look at this this image. Essentially, at the beginning, the deep learning algorithm, it will probably start by identifying the pixel. After it identifies the pixel, so we're in the first layer. Remember, we've got multiple layers. After it identifies pixels, it will probably move on onto the edges, try to identify, some edges. Then it will move on onto the corners, contours. Then it can probably identify parts of the objects. And finally, it can identify an entire object. So this is essentially how the how the artificial neural network, how the deep learning algorithm will work. I will identify, and all of this, so this is that neural network that we've talked about. This is the artificial neural network, and as we said, this is something that's identified by the machine learning algorithm itself. So essentially, we just feed the data, and it will do its magic. So I've got a great example here. We're actually comparing the quality of recognition of the different algorithms in the past. So what we have, this yellow or orange line here, this is the human recognition. So imagine that you give a certain human 100 pictures, and on average, a human can recognize almost 95% correctly. So can tell you what's exactly in these pictures. If we were to take a look at some algorithm in the past in this recognizing objects of the picture, as you can see, around 2010, 2011, the algorithms were way below the what we could get from a human. So we had accuracy about, I don't know, 70%. However, as the time goes by, the accuracy of these algorithms is getting better and better. And nowadays, due to this evolution of these artificial neural networks algorithm, the algorithm actually surpass human in accuracy every single year from, I think it was 2015. So now these these algorithms can actually identify objects much better than you and I could ever do. So we've talked a little bit about machine learning. We've talked a little bit about how the machine learning algorithm looks like, what it composes, so the features and weights. We're also talking a little bit about the different categories of machine learning algorithms. Now, why don't we take a look at how does this machine learning process actually work? How does a machine learning pipeline might look like? So what we can see on the slide is a typical representation of a machine learning pipeline. So any machine learning pipeline should always start with a business problem. So we should always start here. So we should always, try to find a problem that we're trying to solve. All right, so we've got an idea, we've got a business problem. I don't know, maybe we want to identify some customers who might be interested and buy some products. So we need to identify the business problem. Okay, after we've got a business problem, we need to formulate. So essentially, we need to transform the business problem into machine learning problem. After we've done it, after we've articulated a problem and expressed it in a way so it can be used for our machine learning model, now we're gonna find the data. Now we're gonna train our model somehow. So first one, we need to collect all the available information. So you might have information in various databases, data stores, maybe some text information that's printed out in some boxes. So essentially, you need to find, all the available information there is out there. You need to aggregate, so you need to get all the information from that desired place to you. Then what you probably in a real life going to spend most of your time as a data scientist or ML experts or in this position is to actually pre-process the information, because as you know, the data is rarely in the format we want. We always have some missing value, incomplete sets of values, some bad data, error inputs, etc., etc. So we need to do some pre-processing. We need to clean our information so it's usable. At this stage, we also usually do some sort of visualization. So we simply want to visualize the data. It's always good to take a look at basic statistical information, mean of data, median of data, etc., etc. Even visually, seeing the data on a graph can sometimes help us a little bit. So after we've got the data, prepared, we can start extracting important features from our data. So we're starting to identify, which information, which feature we might want to use in our algorithm, and which feature we might not going to use. After we've done it, after we've got an idea, which feature, so what part of data we're going to use, we can start to train and tune our model. So this is usually a very iterative process. This is usually done over and over. You're trying the model with some attribute, with some features. You see the results. You're going to evaluate the results. If you're happy with the results, you can move on. However, usually during the first iterations, the model is not going to be very, very great. So essentially, you will not be happy with the result. So again, you're going to come back to the module, again, tune the model, try to change some parameter, etc., change some features, etc. So essentially, you're going to keep working on your model until you found a model that is acceptable. So whatever your target for the prediction rate was, it obviously, if the model works with, let's say, 10% accuracy, it's even worse than guessing. So that model is probably useless. If you have model with, let's say, I don't know, 80, 90% accuracy, now that's something that's pretty good, that's pretty interesting. So probably we're going to be happy with that model. And then when we're happy, we can deploy the model, so we can use our model not only on the data that we've already had, on the data that we've used it for training, but we can use it, on the data, on the new data. So we can actually, keep using the model in a real life. So I've got a little example on how Amazon actually did use machine learning. So Amazon operates a call centers. It's actually plenty of facilities with thousands of people that work all over the world. So as you can imagine, when it comes to efficiency, being able to connect the customer to a relevant agent as quickly as possible, especially if you're operating on the scale as Amazon does. So you've got tens of thousands of people, maybe hundreds of thousands of customers calling. Every second counts, so you need to be able to do this as quickly as possible. So essentially, Amazon tried to use machine learning for the way how to predict, how to connect, the calling customers to the agent with the relevant skills as quickly as possible. So the business pattern was routing the customers to the correct agent, as we said. So here we've got our machine learning pipeline. Here we should always start our machine learning pipeline with a business problem. So our business problem, hey, we need to connect our customer to the correct agent as quickly as possible. From the business problem, we can actually articulate the machine learning problem. So we need to identify pattern in a customer data that we can use for accurate customer routing. So obviously, when a customer calls us, we do have quite a bit of information about the customer. We probably know, what the customer purchased in the past, etc., etc. So we've got quite a lot of information about the customer, and now we want to use all of this information. So when a customer calls, we can ideally connect him, to the correct agent, even without saying a word. Just do this as quickly as possible because we know our customer. So we now have the business problem, and we now have a machine learning problem. So what we can use is the is supervised learning as the example. So we can actually train our model on a bunch of historical customer data, and we can actually teach our model. So we can tell our model, okay, so in this example, the correct customer agent would be agent A. In this example, the correct customer agent would be agent B, etc. So we can give our model a whole bunch of historical data with correct results. We can tell exactly in this particular situation this is the agent that was, or yeah, this was the agent that was required. So now we're going to move on onto the data preparation and pre-processing stage. Essentially, as we said, this would be about trying to find all of the resources that we have relevant data, all of these different databases, different systems, different environments. So trying to find, all of the places where we have available information. Also, after we've got all of this information, we might want to do a little bit of cleaning if we have, some data with missing value or some malformed data, or if we have maybe some errors in our data. So we might want to find a little bit of cleaning. We might want to visualize our data, and maybe we can also try to identify labels that might be relevant for us. So we have, a whole bunch of information. There might be information that are not relevant, or perhaps there could also be information maybe for some legal reasons we were not able to use. So we'll try to identify the correct. We'll try to identify the correct labels that we want to use in our analysis. So visual analysis will always help. So any kind of data that we have, usually, humans work, people work really well with visualizing stuff. So always what I like to do is visualize everything. Obviously, if I see, graph like this, I can very easily tell what's going on. So visualization is a very important step in the pre-processing phase. So now let's move on. Let's move on onto the feature engineering. So when it comes to feature engineering, we now have to identify correct features. Usually if we have a lot of data, it might not make sense, to use all of the data and also to use all of the data in its raw form. For instance, here we've got an information about the time a customer purchased something. So maybe the information like that is not really relevant for us because let's say if it's been, I don't know, 72 days since the past order, maybe it's not that likely that, customer calls about this product. Maybe if, customer yesterday purchased a different product, that might be more relevant. So we have to think about features. We have to think about the meaning of these features, and we also have to think about if any sort of transformation. So like, what's better for us to know, like a certain date or time, or maybe it might be better for our machine learning algorithm to actually know, how many days passed since the last purchase. Probably the later. So we can do the feature transformation, we can work with feature, so we have better inputs for our machine learning algorithm. Now, the fun part starts. As I said, this is usually how we're going to spend, I don't know, 70–80% of our time. Now, after we've done that, after we've got a good quality data, we can start using it. So we can start training our model. When you actually think about training the model, what's the idea? Do you want to create a model that kind of like remembers all the previous data, and if it's already seen the data, it can tell you an accurate result? Or do you want to create a model that can actually generalize, that can actually, identify these trends, and then it can tell you the result even on the data that it hasn't seen before? So again, it's probably the later stage. So what we usually do while we're training the model, we split all of the available data that we have. We're going to use typically about 80% of data to actually train the model, to actually create, train, and tune the model for ourselves. And then we're going to use the remainder of the data to verify that the model actually works, even on the data that it hasn't seen. So one more time, we're doing this because we don't want the model to remember your data and just work on the data it's shown, but we actually want model to be able to generalize. So that's what we can actually evaluate on this data. So we're going to keep some data aside, and then when we're happy with our model, we're going to use this data, so the data that the model hasn't seen, and we're going to check the accuracy. So how well can model generalize even the data that it hasn't seen before. So that's the fun part. Now we're going to do the tuning of the model. So we're essentially going to evaluate the result, and now we're going to do this iterative process. We're going to tweak the model. We're going to tweak the parameters of the model. After doing that, we're going to run the simulation. We're going to find out how well the model performs. If we're happy, usually we're not happy, so we're going to tune it again and again and again. Yeah, I'm sure you can see where I'm going with this. So this is the iterative process that we're going to tune our model, so our model is better and better and better. At some point, when we're happy with our model, we're gonna see, how the model interacts on these unseen data. So again, verify, that model works really well, even on the data it hasn't seen before. And then when we're happy with it, we can deploy the model in production. So now we have a model in production. We can use this model to predict, whatever we wanted. So for instance, if you created a model that will try to predict, how to connect customer to appropriate agent when a customer calls contacts call center. So now we can deploy the model in production, and hopefully the model would work well. I should probably point out that deploying a model is not the final state. No model would work well forever. So it's actually a very iterative process. Even after the model has been deployed to production, we need to continuously monitor our model. So we need to continuously verify that the model is working according to our expectation, that the module is continuously producing the results that we wanted. And every now and then we need to again come back, fine-tune the model again, and do all of this iterative process again and again. So deploying a model into production is not the end, it's rather the beginning, because now we've got the never-ending part when we need to make things better and better every day. All right, so ladies and gentlemen, that's actually all I had to say about machine learning. So hopefully now you know a little bit more about machine learning. So when someone mentions machine learning, if somebody mentions supervised learning, unsupervised learning, reinforcement learning, deep learning, neural networks, artificial intelligence. So hopefully now these terms are not an empty box or black box. Hopefully now you can imagine what's actually hiding behind all of these terms, so now nobody can fool you talking about things that that nobody understands. Obviously, we only had an hour together, so we couldn't possibly cover everything there is to be covered. So that's why I've got a slide. If you're interested in finding out more information, what I would personally recommend is AWS Skill Builder, which is official AWS training portal. AWS Skill Builder, official AWS training portal, where you can find all the AWS trainings. There are over 500 plus trainings. So whatever you might be interested in, you can find that information. You can find that training, so definitely check out Skill Builder. There is this great course in Skill Builder called ML Building Blocks, Services, and Technology. So if you're interested in learning even more about machine learning, definitely check this one out. There's also the classroom course, Machine Learning on AWS. So if you want to take a course with a real instructor like me today, you can do that as well. And if you probably find yourself lost in all of these different opportunities, these 100 courses and documentation and articles, all of that, if you actually want a curated list that you can take a look at and just go from the top to bottom, we've got it as well. Just check the AWS Ramp Up Guide for Machine Learning, which is a curated list of all of the courses, documentation, blog post links, etc. So if you want a certain order or recommendation, you can do that as well. So, ladies and gentlemen, that's it. I'm hoping that you've enjoyed today's webinar. I'm hoping that it's been valuable, that you now know a little bit more about machine learning. I'm going to wish you all the best. Good luck, and hopefully see you all soon, some other webinar or some other place. So thank you so much. That's all for me. One more time, my name is Tomas. Should you wish to connect and stay in touch, one more time, there is a link to my LinkedIn profile, and that's actually it. That's all I had for you. So one more time, thank you so much. I'm really hoping that you've enjoyed it. There's a link to the final evaluation, so if you have a few minutes left and you want to fill out the evaluations, I'll be super happy about that. It is in the chat, and that's it. So thank you so much. Thank you and goodbye.